everyone, in this video, let's continue number 3. Calculate the final pressure inside a scuba tank after it cools from 1 times 10 to the power of T degrees Celsius, so it's 1000 degrees Celsius, to 25 degrees Celsius. The initial pressure in the tank is 130 atmospheric. So, this problem was we call the Gay-Lussac's law. So, let's begin. So, we have a temperature 1 here, T1. This is a T1. So, T1 is a number 3, right? T1 is equals to 1 times 10 to the power of 3 degrees Celsius is equals to 1000 degrees Celsius plus 273 Kelvin is equals to 1000 plus 273 equals to 1273 Kelvin. So that's a temperature 1. And how about this a temperature 2? T2 is equals to 25 degrees Celsius plus 273 Kelvin is equals to 298 Kelvin. And the pressure 1, which has 130 atm. We have pressure 1 here equals 130 atmospheric pressure. Then the P2 is unknown. So let's solve P2. Solution. Let's use the Gay-Lussac's law's formula, which is P1 over T1 is equals to P2 over T2. So we need to solve the pressure 2. So cross multiply. So T2 times P1. So P1 times T2 is equals to T1 times P2. So P2 times T1. So we need to solve the P2. So divide both sides by T1. Cancel out. The left is P2 equals to P1 T2 over T1. So equals to P2. What is the pressure 1 again? The pressure 1 is 130 atm. So 130 atm times the temperature 2, which is 298 Kelvin here. 298 Kelvin. So equal times 298 Kelvin over the temperature 1, which is 1273 Kelvin. So it's 1273 Kelvin. So you need to cancel out Kelvin, and the left is atmospheric pressure. So P2 is equals to 130 times 298 divided by 1273. So it's equals to 30.43 atm. So that's the final answer. Oh. So let's continue in number 4.